Hello and welcome to today's video, and today I'm actually going to be doing a video on some electronics. So I've actually been working with this one for a while. I haven't done anything with this for a bit. What I have done is I've ordered a potentiometer for the volume control, but I'm not convinced that the volume control is the issue, given some of the advice I've received in the comments to previous videos on this particular unit. So what I want to do, and I'm not sure if this will work that well, is to remove the amplifier chip and see if there is a way of testing it off the board of the unit itself. So I'm just going to try and wrestle this record level one out. Come on, there you go. So why am I doing electronic videos all of a sudden? Well, this is essentially the way that my channel goes. When the weather is good and the season is either spring or summer, I try to focus more on automotive related videos, so how-tos on things that I'm doing with cars, stuff like that. In the winter, I like to change my attentions to sort of more indoor hobbies. So I've got a small collection of consumer electrical items that have been sat on the bench for a while. That includes this, also includes this Bang & Olufsen integrated amplifier affair, and a couple of other things that I want to work on. So the plan is to get those sorted out over winter, and then we're good to go for another season. So let's get all these screws out. All 5 million of them. For some reason there do seem to be a lot of screws in this. And then we can start looking at the amplifier chip and start thinking about unsoldering it. That's not one, this is one. The other thing I noticed, it didn't work on speaker outputs either. Didn't even work with a replacement speaker, so that says to me that we may still have a problem with the amplification chip and not the volume potentiometer. What we will do though is we'll put some contact cleaner onto the potentiometer and leave it to soak and see if we can clean it up a bit. Unfortunately, I'm not using deoxit. I would dearly like to use deoxit, but it is unbelievably expensive, and I can't afford to do it this month, although I'll probably get some next month. If I remember, these are all the same length, which is handy. So we've got 1, 2, 3, 4, 5, 6, I think there's 8 in total. There's another one. Do a quick visual check. Gone, 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 still there, gone, gone. So, this one. Should definitely be ready to come out, and it is. There we go. Right, there we are. So I'll put those to one side, and standard approach to separating it, quite literally, like so. There we are. Now the other thing I did last time was I resoldered the connectors on the speakers because they had come adrift. And what we'll do on this occasion is unplug the speaker connector, which is here. There we go. And that allows us to get the front panel out of the way. There we go. Put that on something soft. Turn this around. And now we can think about what to do inside of here and how to get that amplification chip out. So it looks like we might need to dig into this a little bit deeper. So let's rest it on its back. And let's do a bit of investigation. So that is the heatsink for said amplification chip. This is a very large capacitor which we will test as well, because if that has gone low in value or high in ESR, that'll cause problems. We'll also remove these little ones near the amplification chip as well, and also that one. They're in a similar sort of area, so logic says to me that we should remove them. The board itself looks like a single board confined to this particular area, and we have a selection of a mixture of soldered in place connectors and unpluggable connectors. So we'll need to work out which ones are unpluggable, such as this one on the power supply board. There we go. And which ones we need to trace back in the machine to where they may terminate, so we can get this board out of the way completely. This one is removable, I think. Oh, it's a clippy one, so there you go. Then we've got this one. Things will be a lot easier if I cut the connector here. What we'll do actually is we will zoom in slightly onto the area that we're working on, so that you can get a better view of what we're doing. Apologies for the slight jerkiness there. So this here is one board. We'll actually just come out to about 2.6 on the old zoom. Actually about 1.9 is fine. There you go. So that is the board that we're removing, and it's held in here, here, and there might be another bit somewhere else as well. Actually, I don't know if there is. Anyway, let's get these cut and out of the way, and we'll need to remember what we're cutting, what we're moving, so that when we come back to reassemble, we are putting everything back as it should. So let's start with this one. And actually what I'll do is, if I leave that one in place, oh, too late. We have the video evidence of where it goes anyway, so not the end of the world. So we have this one, which will come away. There we go. This one will go off somewhere else in the machine. What I might do to try and avoid too much disassembly is leave these ones connected, but loosen it in such a way that our wiring is woof. Our wiring is slack enough to allow us to move in and out nicely. So, because we just need the board able to flip out like so, and then we'll be able to unsolder the components that we want to test. So let's start with some screws. Here we go. So one. And there's another one up here, I think. Or is it? Actually, it doesn't look like that one goes through, so we might get away with... Although I think they might be pinned in place, if I'm going to be honest. But let's see how far we get removing these two, and then see if we need to remove any more. There's one. There's the other. There we go. So there's definite moving going on there. There's no screws in the back of this, so it looks like that's pinned into place. So let's see if we remove this one. Do. Why do I get this horrible feeling this whole plastic arrangement needs to come out? Why is that a feeling I'm getting at this precise moment in time? Because I have this horrible feeling that this is held in partly with the plastic arrangement. So let's come out with that one. Let's come out with this one. Let's see where we are now. So there's a definite degree of movement there that we didn't have previously. But I've got this weird feeling that the whole lot needs to come away. So that is just holding that. Ow! That's the shelf that was above me. Yeah, so I'll just zoom out there so you can see what's happening now. have a look over this side. No, nothing obvious on that side. Sorry, my head is going to be in the way whilst I check in here for screws. Sorry about that. So I'm going to remove the 2 screws on this board over here, which looks like the tuner and general processing board. And what do we have here? We've got 1, 2, 3, 4, I think. So it's worth getting that out of the way anyway, because that will give us a bit more space to see what's going on. But I do now have this overwhelming feeling that you've got to remove everything, the whole lot. Which isn't the end of the world, but it's slightly more in depth than I was thinking you'd have to go. However, everything looks unsolderable and easily replaceable, so that's quite nice. Certainly has that going for it, as well as the sort of high quality that these units exhibited when they were new. So this was sort of kind of your premium offering, to be honest with you. Also, this gives us a nice opportunity to investigate the belts on the tape deck, which visually I think they look okay, but this will give us the opportunity to have an even closer look at them. And we are super duper careful, we can carefully unhook the counter, come up and over and rest. Might even be able to unplug and just bring that out of the way for a moment. And appear to have a dead friend. That's sad. Bless him or her. So that is definitely going somewhere. Oh, it's got a nice motor on it as well. And off go the glasses. Right, okay, so that is kind of out the way. Then we've got these two by the looks of it. So these are the connectors on the back, I think. Thankfully, all of the screws in this are exactly the same type of screw, so there's no trying to think where did that go or where did that come from when we come to reassemble it. There you go, so that one is out the way, so that's not going to hold it in place, that's not going to hold us back. That one is, I don't think that's holding us in. Haha! I think I just found one hiding away. There it is. So there. Right. Let's use this as a kind of lever to sort of pull it upwards whilst turning. There you go. Pretty certain that's as out as it's going to be. Cannot really see anything anywhere else where it is still caught up. Unless there is a really obscure screw somewhere. So, not there. Let's have a look under here. No. Ah, hang on. There's one hiding here. Yeah, it's bloody screwed. Oh, that's so annoying. It is actually screwed in round the back into this whole plastic assembly. So to get just one board out, you do need to remove everything. Now, I'm not going to go, oh, the designers, I'm just going to say that makes it a bit of a pain for servicing. However, from a point of making sure that you've got everything rigidly in place and that there's no movement when you're carrying this around, chucking it down, playing some music, picking it up again, going off somewhere else, playing some more music. You don't want it to suddenly develop a loose connection internally. Say one of the wiring connectors come away because the boards have moved. So I can completely see why they've done it the way that they've done it. And if I was looking at the service manual, which I really should, it would probably tell me how all of this goes together. But I haven't done that, even though I do have a copy of the service manual. I'm going to say it's more fun to work it out, which in some ways it is, but sometimes it is actually quicker to consult the manual if you do have access to it. So I'm now just doing a visual inspection to see if there are any more missed screws, because we definitely feel loose on this side, and we have sort of a flex point, appears to be on this board, I would say. Definitely flexing. You can sometimes work out where it is by flexing it and then seeing where the center point of that flex is, and it happens to be this screw here. There we go. And there you are, that's now out. So what we're going to be able to do now is just rest this here for a second. Actually, hang on, what we might even be able to do is disconnect this little connector. There we go. And then whoopsie, that's just come away. That happened. Okay. Oh, there. That plugged into the top of it. So that's removed. That's actually easy to remove because you don't need to dig down into the whole unit. So that can go and sit to one side, which is nice. Then this, if we look at where we're snagging now, it's going to be that aerial. So you can see the aerial there. That is plugged in to there, and there you go. Now we can move this out of the way. So that's the power supply just left in place. That can go out of the way onto a soft resting place. And now we can turn our attention to releasing the board that we want to focus on. So let's have a look at how it is fastened in place. So we've got this one here. There we go. Then we have this one here. And you can see where it is put into this little sort of chassis frame. There we go, and then that can come out, and then this will be free enough for us to work on, so that can go and sit out of our way up here. And then we can focus on the components that we want to remove and test. And definitely this big capacitor. So that pin and that pin, C815. And we're going to focus in on the action. So C815 we're going to be unsoldering. There we go. Got the solder sucker. Somebody asked in a previous comment what manufacturer solder sucker I use. I don't know. It's just one that I purchased on Amazon. In fact, this one may have come from Maplin, if any of our UK viewers remember Maplin. Maplin was bloody brilliant, and it's a shame that it's no longer with us, but there you go. So let's get started with C815. There we go. Nice and warm as well with the iron, so that we have immediate melting capabilities. There we go. Let's see if C815 will come out. There you go, there's C815. Doesn't look too bad, but let's see what the tester says. So this should be a 3,300 microfarad at 25 volts. So let's just pop that into here. It says unknown or damaged part, so let's just turn it around. Unknown or damaged part, okay. So let's test it with the testing prongs. I've just realised, I'm really sorry, I've not focused in on this. Hang on a minute, let me run around and finger in on the tester. So at the moment, with that, it's telling me that that is a damaged or unknown part when plugged into the test socket. So what I'm going to do is use the test probe as well. Do a test. That doesn't look great, if I'm going to be honest. Okay, ESR 0.75 ohms, VLOS 2.7%, 2,649 microfarads. It's not brilliant, it's low in value. ESR's okay though, it's just 0.75 ohms. But it's not in the best of shape, unfortunately, so we will replace that one. If it was showing near 3,300 microfarads, then it would be going back in, because there's no point in replacing something if you don't need to replace it. I've actually got another multimeter here which we could use to test with. So microfarads. Got my probes. Yay, probes. There we go. See what this one tells us. That might need actual voltage going through it rather than seeing if it works this way. So that's probably the one I'll rely on for testing. This one is, I think, if it's live in the circuit, which obviously it isn't, so let's run another test on this. Yeah. So that one is for replacement, and what were the other ones I wanted to focus on? The little ones within the immediate vicinity of the IC itself. So C804, C803 and C814. So C804, start to unsolder that one. So C804. I think it was C804, C803 and C814. So C804, got C803. One of the joints on that actually looks a little bit dry, if I'm going to be honest. C804, so let's go to C804. There we are. So we're doing C803 at the moment. That's C803. C803 is out-ish, I think. There we go. C803 is 100 microfarads at 10 volts. Test that in a minute. We want to do C814 now. So C814, which is this one. C814. 804 is over here. There we are. This one is 100 microfarads at 10 volts. And then that one, which is 814, is probably another, looking at it, 100, oh that's 50 microfarads, sorry, 4.7 microfarads at 50 volts. That one's a bit bigger. Right, so let's test this one first. It's usually these smaller ones that tend to give out rather than the bigger ones. 2.1% ESR, 4,825 nanofarads, so it's about right, but we'll replace it anyway. (83.72 microfarads, ESR 1.4%. I think the ESR is within, but the microfarad rating is low, so that could be do with replacement. And then we've got this one. (84.27 microfarads, ESR 1.5 ohms, and that one's a bit low as well. So yes, they are low in value, and we have others. We've got C835, so I'll bring out C835 as well. So C835 is here. That doesn't seem to, although I'll be honest with you, that doesn't seem to touch the amplification chip directly, whereas C814, C803, and I think C804 do directly touch that chip. So in other words, there is a direct track going to one of the pins on the amplification chip. That big fat one, C815, is feeding into, actually C816, that's another one. We'll take out C816 as well. As I've seen this on my Sony F1, that if the capacitors are dry and open circuit, they can take out any silicon further down the line. So in this case, it would be this amplifier chip may have gone on one of the channels because dry capacitors have taken it out quite literally. It's definitely worth getting that out of circuit and testing it. There we go. So that is C816, and C816 is, oh, it's one of those. Well, they don't normally go wrong, to be honest with you. It's not an electrolytic, it is one of these. I've forgotten what they are, but they're not electrolytic capacitors. I'll test it anyway. That one might, yeah, 0.2%, 97 nanofarads. Now I need to work out which is the positive leg, because I've just taken it out and I'm not sure which side is positive. Have a look at the others. C806 can go back into operation. However, actually, before I put it in, I'll just put it back in. Actually, I don't think these ones are poled, so I don't think they have polarity. So C816 can go back in because these ones don't normally give us issues. Okay. There we go. I think that one's back in. Is that ready to receive some solder? Yes, it is. There we go. Check that anyway. It was worth checking, but that just proves that those rarely give us problems. Okay, so C816. Very clean. Come in. So, blob of solder and blob of solder. There you go. That's back in circuit. Right, let's take out the amplification chip now and see if there's any way we can test it at all. So, a couple of screws now holding it in place. There you go, you can see the screws there. So let's pop those out and then we should be able to get the chip itself out. Sorry. Okay. Ah! There you go. It's out. So what we need to do is get a data sheet for that chip, which is a Hitachi 1F4 HA392. And once we have said data sheet, we can then test for continuity between the pins to see if anything has burnt out internally. And if it has, then we'll be in a better position to determine if it needs to be replaced. Well, I've got a feeling it probably might, judging by what people have said. So once we've tested it, we'll be able to see exactly where we are, but we'll probably be needing to replace it anyway. Let's have a look at this one. Let's see where that sits in the grand scheme of things. It isn't in direct line with the chip itself. We'll need to clean all of that up. And there we go. Okay, I think that's it for today. So I'm going to put this all back into the case. Not screw it back in, but just put it back into the case so that it is isolated. The only board I really want to... So the only bit I really want to keep out is that chip, so we can get a data sheet on it, test it, and ultimately probably replace it, to be honest with you. What we'll also do off camera is put some contact cleaner onto the various pots. So we'll not only do the volume pot, we'll also do treble and bass as well. We may as well, whilst it's apart. And next time, what I'll probably do, to be perfectly honest with you, is replace that anyway, but we'll test it as well to see if indeed it is failed. That's not even a phrase, that's terrible grammar. Terrible grammar. To see if it's actually failed, or if it's possibly the surrounding components that have failed. So in this case the capacitors, because they are looking a bit ropey, to be honest with you. So replacing them is not going to be to our detriment in any way. But to reduce costs, I don't want to just do a blanket replacement of all of them. That's why I'm focusing on ones which are dealing with the amplification chip directly and leaving the other ones where they are. Anyway, hope you've enjoyed this video. It's actually been quite nice getting involved again with some electrical items, sort of a bit of a change. Don't forget to like and subscribe, and if you've got any suggestions as to what the issue might be, or indeed if I'm going in the right direction with this, let me know, because I'm still learning, so I'm always happy to take on politely given advice and criticism. However, if you just want to be a troll, you can also go ahead, because it does drive engagement, but don't expect any kind of response, really. You'd be wasting your time and effort, if I'm going to be honest. It's tiring to read, but quite amusing as well. Anyway, thank you very much for watching. Take care, and see you soon. That doesn't even work, but there you go. See you soon.